as we see more and more robots that work in close proximity to workers, we try to increase the acceptance so that the worker enjoys working together with these robots.
What we know from decades of prior research on human-robot interactions is that the concept of anthropomorphism is something that leads to greater liking, that leads to better expectations in terms of performance, for instance. It's something that is very well reasoned over decades of research, that there are a lot of positive effects of making something more anthropomorphic. So you give it, for example, a more visual appearance, you give it a human-like face, or you change the parts, for instance, of a robot to make it more human-like, and with all the positive consequences. But what is interesting to us is that when you think of industrial robots, there's just no point to make them more human-like, to give it a more human-like face, for instance, or to change the body parts, for economic reasons, but sometimes also for safety reasons. So, and that was really the moment when this research idea was born. Can we change an industrial robot and make it more human-like merely by changing the movement patterns of the robot?
For example, speed, if we let the robot move slower, that is perceived more human-like. With regard to rotation, a conventional number of rotation is perceived more human-like than additional unnecessary rotations. Smoothness refers to the robot's trajectories and the rounding of edges. So a more steady movement is perceived more human-like than a jerky, stopping, rather nervous movement of the robot. And we've also seen that there is a strong correlation between perceived human likeness and preference for that movement behavior.
Apparently, there's a bit of a paradox. So you can design robots that are perceived as more human-like with all the positive consequences. People trust it more, people think it's better in terms of performance or perceived performance. But objectively, when we find if we make things slower moving or we design more smooth movements, people like it more, but the efficiency gains are lower, obviously. So it's a bit of a conflict that is not resolved yet, but we think it's a starting point to rethink the way how we design robots in the future.
We would like to grow this into a personalized robotic system, into a robotic system that could understand who you are, what you are specifically, you as an individual, are specifically expecting from a robot, and how the robot could ideally satisfy these expectations through its behavior. If you're a timid person, maybe the robot could notice this and could move more slowly. If you're a person who is full of energy and full of motivation to do things, you might move faster. So we're looking for this kind of individualization with our robots. Second, we are looking to transfer our results to different types of robots. So we have ascertained that we can anthropomorphize essentially robots that don't have a face, that don't have eyes, that don't have traditional, typical human features. What we would like to do is to transfer this to robots that don't even have an arm. Maybe a robot like an automated vacuum cleaner that could approach you more timidly if you don't like it or if it notices that you are a bit afraid of it.